Now here we are having the second example of logarithmic recurrence relation method. Now I want to change one thing, that logarithmic recurrence relation method is also called as change of variable method. That is, logarithmic recurrence relation method is also called as change of variable method. Fine. So whenever there in the university examination, if the question ask like solve the following using change of variable method, then that is nothing but the logarithmic recurrence relation method. Fine. So here we are having the second example of change of variable method. So how to solve it? First of all, you have to write the t of n term, that is the otherwise condition given to us, 2t n by 2 plus n log n. Fine. So here first of all we have to change the value of n. That is, we have to place n is equals to 2 to the power I. So t of 2 to the power I is equals to 2t n by 2, that is 2 to the power I divided by 2 plus 2 to the power I log of 2 to the power I. Fine. So here we have to take all the t term on the LHS side and rest of the term is on non-t term on the RHS side. That is t of 2 to the power I minus 2t 2 to the power I divided by 2 is equals to 2 to the power I log of 2 to the power I. Fine. So here we can put 2 on the numerical side. So after putting it and putting common 2, we will get t of 2 to the power I minus 2t 2 to the power I minus 1. Fine. Is equals to 2 to the power I. If I want to take the log of this, how will I will take 2 to the power I into log of base to 2. Fine. Then you must know one thing, that is log base of n, and n is equals to 1. Fine. That means as log of n to the power n is equals to 1. That means log of base 2, and again the value is 2. That means n is equals to n. That means it becomes, whole term becomes 1. That means t of 2 to the power I minus 2t into 2 to the power I minus 1 is equals to 2 to the power I into I. Fine. Now this is our LHS part, and this is our RHS part. Fine. So on the next in the next step we can solve, we can find out the roots of LHS and RHS, and then I will combine both of them. Fine. So how I will get now my next step is step 1, my first step. Fine. So I have to take the root of, take first of all LHS part to find roots. Fine. So what is my LHS part? LHS part is t of 2 to the power I minus 2t 2 to the power I minus 1 is equals to 0. Fine. So I will put 2 to the t of 2 to the power I, that becomes x to the power 1, and t of 2 to the power I minus 1, that means x to the power 0. Fine. What I am doing, I am putting t of 2 to the power I is equals to x to the power 1, and t of 2 to the power I minus 1, that becomes is equals to x to the power 0. That means what I will get, x to the power 1, that is x minus 2 is equals to 0. That means my first root, that is r1, is equals to 2. Fine. So by solving RHS side, again step 2, I have to solve the RHS part of it. On solving RHS part, we will get the roots of RHS part. Fine. So we have to find roots of RHS part. To find roots of RHS part, we have to compare it with b to the power I into p of I. Fine. So what is RHS part? That is 2 to the power I into I is equals to b to the power I into p of I. Fine. So I will compare it with the exponential term is 2 and then polynomial term is I. Fine. So I will divide it into the two part. That is b to the power I is equals to 2 to the power I and p of I is equals to I. Fine. That means on comparing b with that exponential term, b is equals to 2 and p of I is equals to I to the power 1. That means what? How many time I will repeat the root? That is d plus 1 time I have to repeat the root. Fine. So what is the value of d? D is equals to 1 plus 1. That means I have to repeat the root 2 times. What is the root value? Root value is 2. That means what on solving RHS part, how many roots I am getting? I am getting 2 roots, that is R2 is equals to 2 and R3 again is equals to 2. Fine. Now in the next term, that is step 3, what I am doing? I am combining both of the roots. That means step 3, I am combining both of the roots, that is roots calculated by RHS as well as by LHS, that is R1 is equals to 2, R2 is equals to 2 and R3 is equals to 2. Fine. So what is the generalized equation for all of these roots? That if the roots are, we can observe here, roots are real and same. Fine. Roots are real and same. What is the generalized equation for it? T of n is equals to I am here delivering here the next constant instead of a b and c, that is x1 into r1 to the power I plus x2 into r2 to the power I, sorry, here I into x2 into r2 to the power I plus I square into x3 into r3 to the power I. Fine. So t of n term is equals to x1 into, what is the value of r1? R1 is 2 to the power I plus I into x2 into r2 is 2 to the power I plus I square into x3 into r3 is again 2 to the power I. Fine. So this is my generalized equation, but here the RHS side is I's term. Fine. So how I will get the how I have to convert this into the n term. So n is equals to 2 to the power I. N is equals to 2 to the power I. I have to take log on both sides, that is log base to 2 of n is equals to I into log base to 2 of 2, and here we can say log base of n to the power n is equals to 1. Fine. That means this value becomes 1 in the future. That's why log base to 2 of n is equals to I. So what is the I value? Log base of 2 to the power n. Fine. So t of n. Now I am putting I value in my generalized equation. T of n is equals to x1 into 2 to the power log base to 2 of n plus I into, that is I, what is I? Log base to 2 of n into x2 into 2 to the power log base to 2 of I, log base to 2 of n plus I square, that is log base to 2 of n whole square into x3 into 2 to the power log base to 2 of n. Fine. So this is my generalized equation. I am calling this equation as equation A, capital A. Fine. So after getting generalized equation, what is my next step? That is my step 4. I have to use the initial condition what is given there. Initial condition or initial equation that is given there. So T of n, what is the initial condition? If n is equals to 1, then T of n is equals to, that is T of 1 is equals to, what is the value of T of 1? 1. Fine. So I am placing this n is equals to 1, that is put n is equals to 1 in equation capital A, that is my generalized equation. So T of 1 is equals to x1 into 2 to the power log base to 2 of 1 plus log base to 2 of 1. I am putting the value of n here. Fine. Log base to 2 of 1 into x2 into 2 to the power log base to 2 of 1 plus log base to 2 of 1 whole square into x3 into 2 to the power log base to 2 of 1. Fine. So what is the value of T of 1? T of 1 is 1. What is the value of T of 1? T of 1 is 1. Fine. So after putting log base to 2 of 1 in the calculator, which value I will get? I will get value of log. Fine. So I am showing here to how to get value of from the calculator of calci. Fine. So what is the value of it? Value of it is log. Fine. What is the what is the base power? Base power is 2 here, and what is the power? 2 to the power 1. Fine. So of 1. Fine. So what I am getting here? I am getting here 0. What I am getting here? I am getting here 0. That means 2 to the power 0. Fine. So here x1 into 2 to the power 0, that means any of the term that is n to the power 0, that becomes 1. Fine. So 2 to the power 0 plus 0 into x2 into again 2 to the power 0 plus 0 square into x3 into again 2 to the power 0. Fine. This term becomes 0 and this term becomes 0. So what is the value of x1? x1 here is equals to 1. x1 here is equals to 1. Fine. So this is my first equation. I am getting here the first equation. Fine. So on the second equation, as there are how many unknowns here? x1, x2 and x3. So we have to calculate the 3 equations and then we will get the 3 unknown value. Fine. So remember here in the logarithmic equation, what can be the value of n? Next consequent value of n. In the non-homogeneous equation, if n is equals to 1 in the first condition, then we will put n is equals to 2, then n is equals to 3. If 3 constants are, 3 unknowns are there. Fine. So but there in the logarithmic equation, what we are getting here, n is equals to 2 to the power I. We are using here n is equals to 2 to the power I. Fine. So first condition of n is 1. So how I am getting 1? By putting 2 to the power 0. 2 to the power 0, that becomes 1. Fine. So n is equals to 1 here. We have to remember here for this chart for the logarithmic equation. Fine. So if I am putting 2 to the power 1. Fine. If I am putting 2 to the power 1, what is the value of n that I am getting here? N is equals to 2. What is the value of n that I am getting here? N is equals to 2. Fine. So what can be the next consequent value of n? That is 2 to the power 3. I am putting, if I is equals to 0, here I am getting n is equals to 1. If I am putting I is equals to 1, here I am getting n is equals to 2. What is the value, next value of n? If I am putting here that is I is equals to 2 here. So 2 square, that is n is equals to 4. Fine. So if three unknowns are there, then if n is equals to 1, if n is equals to 1, so what can be the next consequent value of n? After putting n is equals to 1, what is the next consequent value of n? N is equals to 2. Fine. So what is the next consequent value of n? N is equals to 4. Fine. So what is the next consequent value of n? After putting here I is equals to 3, that is 3 here, that is the 2 cube, that is 8. So n is equals to 8 here. Fine. So to find three unknowns, n is equals to 1 is my first value, second value is n is equals to 2, third value is n is equals to 4. Fine. If 4 unknowns are there, then value of n is equals to 1, then 2, then 4, and then 8, and so on. Fine. So we have to use this table for using the initial condition and putting n is equals to whatever the value. Fine. So for this which condition I am using? N is equals to 2 here. Fine. So my next step, that is step 5. So what is my next step? Put n is equals to 2 in initial condition or initial equation, we can say it as. So what is the initial equation? T of n is equals to 2t n by 2 plus n log n. So what is the value of n? N is equals to 2, that is t of 2 is equals to 2t n by 2, that is 2 by 2, that is 1, plus 2 into log 2. Fine. So 2 into log 2. So what is which value I will get? T of 2. T of 2 is equals to 2t. T of 1, that is 1. 2 into 1 plus, what is the value of here? 2. If I want to get this value, 2 into 2, 2 into 2 into log base to 2 of 2. What I am doing here? I am what I am doing here? I am calculating the log value of it. Fine. So what is the log value of it? Is 2 into log of 2 by 2. Fine. But this value is equals to 1 here. Fine. So t of 2 is equals to, I will get t of 2 is equals to 4. I will get t of 2 is equals to 4. Fine. So here the next step is use this value of t of 2 is equals to 4 in the generalized equation. Fine. So what is my next step? That is put n is equals to 2 in my generalized equation, that is equation capital A. Fine. So what I will do here? I will write the generalized equation, that is t of 2 is equals to, what is the generalized equation? That is x1 into 2 to the power log of 2 of 2 plus log of 2 of 2 into x3 into 2 to the power log of 2 of 2 plus log of 2 of 2 whole square into x3 into 2 to the power log of 2 of 2. Fine. But t of 2 is 4 is equals to x1 2 to the power 1. Log of 2 of 2 is 1. Fine. So 2 to the power 1 plus 1 into x3 into again 2 to the power 1 plus 1 square into x3 into again 2 to the power 1. So what is the next equation? 4 is equals to 2x1 plus 2x2 plus 2x3. Fine. So this is my second equation. Fine. So this is my second equation. Now what is my next step? That is step 6. What is my next step? Step 6. that is put n is equals to, not here 3, I will use the next n value. Next n value after 2 is 4. Fine, n is equals to 4. Put n is equals to 4 here in initial equation. So what is my initial equation? T of n is equals to 2t n by 2 plus n log n. Fine. So t of 4 is equals to 2t n by 2, that is 4 by 2, t of 2 plus 4 into log base to 2 by default into 4. Fine. So t of 4 is equals to 2 into t of 2 is 4 here plus 4 into I have to take now the log of these values. So how I will take? I will take using the formula. Fine. So what is the value of log of 4 of 4? That is 2. Fine. So t of 2 into 4 plus 4 into 2. Fine. That is 2 into 4 into 2. And log of 4 of 4 is 1 here. Fine. So I will get here t of 4 is equals to 8. Sorry, one thing. So t of 4 is equals to 8 plus 8, that is t of 4 is equals to 16 here. Fine. So now what is my next step? My next step is put n is equals to 4 in equation A, capital A. That means what is my equation capital A? T of 4 is equals to x1 into 2 to the power log of 2 of 4 plus log of 2 of 4 into x2 into 2 to the power log of 2 of 4 plus log of 2 of 4 whole square into x3 into again 2 to the power log of 2 of 4. Fine. So t of 4 is 16 here. T of 4 is 16 here is equals to x1 into log of 2 of 4. What I will get? I will put that value directly into the calc. So log of 2 of 4 I will get is equals to 2. Fine. So x1 into log of 2 of 4, 2 to the power 2. This value after putting there in the calculator, what I will get? I will get the log value as I will get the log value as 2. Fine. So x square plus 2 into x into 2 to the power square again plus 2 square into x3 into again 2 square. Fine. So what I will get? 16 is equals to 4x1 plus 8x2 plus 16x3. Fine. So this is my third equation. This is my third equation. Fine. So after having all of these values, so put it directly into the calc. That is equation 1. After putting equation 1, 2 and 3 in calc, what I will get? I will get the value of x1, x2 and x3. Fine. So I am today showing here how to use calculator for all of this. I have to go there into the mode here. Then I have to use the fifth one, as there is we have to solve the equation. As there are how many unknowns? There are three unknowns. Fine. So I have to use here the second number, that is fine. So what is the value of first what is the value of first equation? First equation value is x is equals to 1. Fine. So x1 is equals to 1. So I am putting here x1 is equals to 1 here. And so after putting all the values, first equation I have put the value, second equation is 2x1 plus 2x2 plus 2x3 is equals to 4, that is the value of D. Then next equation is 4x1, now next is 8x2 plus 16x3 is equals to 16. Now I will get first value of x1 is 1, that is here. Next value is 1 by 2, and third I am getting value of x3 is, that is z value is 1 by 2. Fine. So I have to use all of these value and put it in the equation capital A, that is my generalized equation. So T of n is equals to x1 is 1 into 2 to the power log base 2 of n plus log base 2 of n into x3 is 1 by 2 into 2 to the power log base 2 of n plus log base 2 of n square into again 1 by 2 into 2 to the power log base 2 of n. Fine. So what is my next step? Can I optimize again the equation? Yes, I can optimize the equation by putting 2 to the power log base 2 of n as a common. So 2 to the power log base 2 of n is into 1 plus log base 2 of n by 2 plus log base 2 of n square into square by 2. Fine. Into 1 here. Fine. So this is my solution for this numerical.